right, class, the last section of Chapter 2 is Section 6.2, which is a really brief and short section, and it's just all about function notation and linear functions. So remember, a function is a relation where each x has a unique y value. You can also test if a graph is a function using the vertical line test. So when a function f is defined with an equation using x and y for the independent variables, we would say y is a function of x. So in order to emphasize that y depends on x, instead of using y, we can write f of x. So as before we had, let's say y equals mx plus b, we know that the graph of all non-vertical lines is a function, and because it's a function, we can write it f of x equals mx plus b. F of x is really just another name for y, as long as we're working with a function. So here's our basic linear function, like y equals mx plus b, where a and b are real numbers. This is a linear function. A is our slope, b is our y-intercept, and the domain, that means all possible x values that this function can take on, is always going to go from negative infinity to positive infinity unless it's specified otherwise. So in order to put something in function notation, we solve for y and then replace y with f of x. So for number 1, I have 5x minus 4y equals 9. I'm going to subtract 5x from both sides. That means I have negative 4y equals negative 5x plus 9. I divide both sides by negative 4 to get y all by itself. I then have y equals 5/4 x plus, not plus, minus negative 9/4. So I could rewrite this as f of x, meaning this function depends on x, f of x minus 9/4. All right, let's do one more example. Let's switch to a nicer color, SLU blue. So for number 2, we've got negative 6x plus 2y equals 8. We go ahead and solve for y. The next thing we're going to do is divide by 2 on both sides to get y all by itself. And then we can rewrite this using function notation. So f of x, so the function depending on x, is 3x plus 4. And that's it. That's all you needed to know about putting functions in function notation.